Alright, today I'll be explaining Homework 3 Part 1, which is a closed water and air system. And so, what's happening in this problem is there's a container which is open to the air, as you can see up here, and it's got a certain amount of water in the bottom, and then it is closed off and heated up. And so then there are particles of air here, and then there's H2O in there. And then over here, it's been heated up, so molecules of water have now entered the vapor phase with the air. So there's now air and H2O in the vapor phase, along with water in the liquid phase as well. And so what we are given is the mass of the water initially, which is 1 kilogram, and then the temperature initial, which is 298 Kelvin, and we're also given the pressure initial, which is 1 bar, which is equivalent to 1 times 10 to the 5th pascals. And then as you go over here, as the water then enters the vapor phase, you have 0.3 moles of water in the vapor phase. So this, we'll call this NH2O in the vapor phase. And then in addition to this, we also are given a final pressure, which is pressure final equal to 2 bar, which is 2 times 10 to the 5th pascals. Alright, so from here, we now are looking for our total volume of the system and our final temperature of the system. And so in order to find this, we will first write out Dalton's law, which is the sum of the partial pressures. So we have our pressure total of the system is equal to the partial pressure of the air plus the partial pressure of the water. And in addition to this, we also have our ideal gas law, which is, put that right here, which is PV equals nRT. And then in order to find our total volume, that will be equal to the volume of the vapor phase plus the volume of water in the liquid phase. So let's call that LW. And we're given the mass of the water up here, which will help us find the volume of the liquid water if we do the mass divided by the density of water, rho. And that will give us our volume of liquid water. And so this equation, I'll bring that down here, we can do pressure final is equal to the pressure of the air, which will be used from the ideal gas law, a variation of it, the moles of air times the gas constant R times the final temperature divided by the volume in the vapor phase plus this value here, which is determined through the Antoine equation, which will be done in a shortcut in the code, so I won't explain that here, but just to know that it's here, we'll do the partial pressure of the water in the vapor phase at a certain temperature, which will be temperature final. And then from here, we will then do the moles of water in the vapor phase, which was given up here, will be NH2O in the vapor phase is equal to the partial pressure of the water times the volume in the vapor phase divided by the gas constant divided by the final temperature. And so then, by using this, we can then have the volume of the vapor phase on one side and plug into here and here. And if we do that, we will then have two equations with two unknowns. And so then here it'll be volume of the vapor phase is equal to the total volume minus the volume of the liquid water. So if you plug that in to here and here, we will have V total in both equations and temperature final in both equations. So as you can see here, we now have two equations with two unknowns, which will now be solved in the video coding this.